In section 3.3, we're going to talk about future value of an annuity. An annuity is any sequence of equal periodic payments. So what sets section 3.3 apart from the first two sections, section 3.1 and 3.2? One of the key things that we get with an annuity is we have multiple payments or deposits. Okay, so with an annuity, you don't just make one deposit or one payment at the beginning and let the money sit there. With an annuity, you make multiple payments or deposits throughout the duration of the loan into the account. And each of these payments are exactly the same amount. They have equal value. Okay, the second thing that sets a future value annuity apart from other things that we're going to look at is that the amount in the account is increasing. Okay, so these two things are really important. I frequently get asked, which formula should I use for this problem? So in your Exam 1 study guide that's posted in D2L, I have included a little chart. What formula should I use for this problem? You want to read through the problem and ask yourself these questions. Question number 1 is how many deposits or payments are being made? If there are multiple deposits or payments being made, then we're talking about an annuity of some sort. The next question would be, is the amount in the account increasing or is the amount in the account decreasing? If the amount is increasing for those multiple payments, then we're going to use that future value formula. So that's what we're going to talk about here in section 3.3. Okay. If you ask yourself the question, how many deposits are being made, and your answer is only one at the beginning of the account or the loan, if you're only making one payment or deposit at the very beginning, then the second question you would ask yourself is, are you seeing the word compounded in the problem? Okay, so if you're making only one deposit and you see the word compounded in the problem, then you're going to use those compound interest formulas. Okay, we have two of those. Only one of them is for if you see the word continuously. If you go back up here and you say, yes, I'm only making one deposit, but I do not see the word compounded in the problem. If the answer to that question is no, then you're going to use simple interest formulas. And so here are those three simple interest formulas. So this guide is included on your Exam 1 study guide at the end. So make sure that you're aware of the features of each type of account that we're talking about. Alright, so we're only going to use the future value of an annuity formula if we have multiple payments or deposits being made into the account and the amount in the account over time is increasing. Okay. If the payments are made at the end of each time interval, then the annuity is called an ordinary annuity. We are only going to work with ordinary annuities. The future value of an annuity is the sum of all of the payments that you made. So all of the deposits that you made, we're going to add those up together, plus we're going to add in all of the interest that gets earned. So in the end of the account, you will have all of your payments plus all of the interest that you earned on the payments that you made. Let's look at an example of what we mean by a future value annuity. Suppose you decide to deposit $100 every 6 months into an account. So let's stop there. Every 6 months you're going to deposit $100. So for 1 year, every 6 months, okay, that means you're going to make a deposit at the end of every 6 months. That's twice a year. So for that first year, you're making 2 deposits. Okay, so the next question says, okay, so the next part says that the account pays 6% compounded semi-annually. Okay, let's think about the word semi-annually. Semi-annually means we set an M value of 2. That means that the interest is getting calculated twice a year. Okay, so those two things are going to go together. The amount of times and the frequency for which you're depositing the money is also going to come in combination with how many times per year that the interest is being compounded. So you're depositing money twice a year and the interest is being compounded twice a year as well. So those two things are always going to match up. right? Okay, so we're going to do this for 3 years. So it says that we're going to make 6 deposits. So let's look at this timeline. The timeline has the first year here. Okay, so we see within that first year we've made 2 deposits. So we're going to continue to do this for another year. So here's the end of the second year, and we've made 2 more deposits. And here's the end of the third year, and we've made 2 more deposits. So we're doing this for 3 years. So we have a total of 6 periods or 6 deposits in this timeline. At the end of each interest payment period over those 3 years, how much money will be in the account after the last deposit is made? Okay, so let's look at what happens to the money when you deposit it. So we're depositing at the end. Okay, so that's one of the ideas of the ordinary annuity, that the deposits are made at the end, and the interest is going to get calculated as it sits for that next full period. So we get to calculate interest once, twice, 3 times, 4 times, 5 times. So that $100 that you deposit at the end of the first 6 months is going to have interest calculated 5 times. So how much money, how much interest will that $100 have earned when we get to the end? So actually, in order to calculate the future value of that $100, we could use our compound interest formula. Okay, so it's actually having the interest compounded several times, once every 6 months we said. So let's go ahead and use our compound interest formula to answer that question. How much is being deposited? Well, for that first $100, our principal is $100. And then 1 plus the interest rate, which was 6%. So it's 0.06. We said semi-annually, our M value is 2. Okay, so I'm going to do 2 times our T value. And our T value here, if you look at our timeline, is actually only 2.5 years. So I can multiply that by 2.5. Now 2 times 2.5, I put that in my calculator, and I'm going to get 5. Okay, so what we have here then is, here's the formula right here, simplified, because 0.06 divided by 2 is 0.03. 1 plus 0.03 is 1.03, and then raised to the power of 5. So this is the future value, so including the original $100 that you deposited here and all of the interest that you earned. This is the future value of that $100. Now that $100 is going to sit in the account longer than any other deposit that you make. So what happens with the next one? The next one, $100 that you deposit, is going to come at the end of the first year, and so the first time interest gets calculated is in the next period. So the interest on that second $100 gets calculated 1, 2, 3, 4 times. So when I used the compound interest formula, I ended up with that as a future value. So that amount includes the $100 that I deposited, including any interest that was earned. Okay, and so the third $100 that gets deposited earns interest 1, 2, 3 times. So that's the future value of that $100. The fourth $100 that you deposit earns interest twice. So there's the formula for the future value of that $100. The fifth $100, the interest only gets calculated 1 time, so there's the formula for that. The last $100 actually earns no interest, so you just deposit that $100 and then that's it. If you wanted to find the future value of this account, you would take all of those future values and you would add them all up together. When you do all of those individual calculations in your calculator and then you add all of those up together, you get about $646.84. So that would be the future value of that annuity. How much interest have you earned? So let's ask that question. How much interest have you earned? If that's how much is sitting in the account in the future, how much interest have you earned? Now we know that all of that isn't interest, right? Because didn't we make some deposits along the way? Yes, we did. We made $100 deposits 6 times. So we're going to subtract from that future value the $600 that we deposited. Okay, so I'm going to write this out next to the values. We have the future value of that annuity minus, we're going to subtract off the total amount that we deposited. So we didn't deposit just $100, we deposited $100 6 times. So I want to make sure I subtract off the full amount or the total amount that we deposited throughout the duration of the annuity. And what we have left over after we do future value minus total amount we deposited will be the interest that was earned for the duration of the annuity. So I get $46.84. Okay, so you want to keep this handy. This is going to come up again for finding the interest that was earned on a future value annuity. Now, instead of doing each one of those individual calculations for each deposit and then adding all those deposits up and those future values, instead of doing all of that individually, we have a formula that's going to do all of this at once. Okay, so this is the formula that I want you to use for a future value of an annuity. So FV stands for future value. Okay, so there's two things again in order to use this formula that must be true. Number one, you have to be making multiple payments or deposits. Secondly, in order to use the future value annuity formula, you need for the amount in the account to be increasing. All right, so if those two things are true, then you can use the future value annuity formula. So FV, we said, stands for future value, so that's how much will be in the account in the end, including all payments and interest. The payment, the equal payment that you're making every period, that's going to be represented by PMT. The R value, again, is that interest rate written as a decimal. The M value is the number of times per year that you are having interest calculated or making deposits. So that turns out to be exactly the same thing. All right, and the T value is the length of time in years. So one little note that we have here, for improved accuracy, keep all values in the calculator until the very end and then round at the very end to the number of required decimal places. Okay, so that's usually to the nearest cent or to the nearest 2 decimal places. We don't want to round and then put the values into the formula. We want to put everything into the formula and wait to round until the very end. So let's use this formula for the example that we have above. Okay, so for the example that we had here, instead of doing all of those individual calculations, let's just do one calculation here. So that would be future value is equal to payment. So the payment was $100. Okay, we're going to multiply all of that times this big fraction. So it's going to be parentheses 1 plus that interest rate. So we said that our interest rate there was 6%, so that's 0.06. Dividing that by our M value, which was 2. Scroll down a little bit. Okay, and then we're going to raise that to the M times T power. So the M value was 2, so we're compounding the interest semi-annually, so that's twice a year. Times the T value, we're doing that for 3 years. Then we subtract 1 from the top of that fraction. Okay, and then at the bottom we're going to divide that by another fraction. That's the interest rate divided by the M value, which was 2. Now what I'm going to do is I'm going to take that formula and I'm just going to put all of that into Desmos and let Desmos do all of that work for me. Alright, so here I have Desmos. I'm going to type in 100. I'm going to multiply that times, I need parentheses, and I'm just going to type in the top of that fraction. So inside the parentheses I'm going to do 1 plus 0.06. We're going to divide that by 2. You want to make sure that this looks almost identical to what we have here inside of those brackets. Okay, then we're going to come outside of the parentheses and I'm going to raise that to a power. And I'm going to put the power in the parentheses just in case. And I'm just going to type in 2 times 3. I'll let my calculator do all the work for me. Come outside of that parentheses and I'm going to subtract 1. Now I want to make sure all of that goes on top of the 0.06 divided by 2. So I want all of that to be on the top of the fraction. So I'm going to highlight everything that I've typed except for the 100 there. And I'm going to hit divided by. So all of that now is at the top of that fraction. And then I'm going to type in my 0.06 and divide that by 2. And I get $646.84 when I round to the nearest 2 decimal places. And that's exactly what we got here. Okay, so you want to be able to use that formula, plug all of those values in, and then get that future value. If you are asked about the interest, you will take this future value, subtract off all of the amount that you deposited, and the leftover value will be the interest that got earned. Okay, so make sure that you can type all of that into your calculator. Just expand this a little bit so you can see the 100. Make sure you know how to type all of that into your calculator and then get the future value of that annuity. Alright, so for this example, we're asked what is the value of an annuity at the end of 10 years if $1,000 is deposited every 6 months into an account earning 8% compounded semi-annually. How much of this value is interest? Okay, so we have 2 questions there to answer. The first thing that I want to mention is that we are making multiple deposits. So we are depositing $1,000 every 6 months. So this is multiple deposits. If you are making multiple deposits, then we're not talking about simple interest, and we're not talking about compound interest. When you're making multiple deposits into an account for the duration of a loan or some account, then you are talking about an annuity. Okay, so the second question you would ask yourself is the annuity increasing in value or decreasing in value? And so it looks like it's going to be increasing in value because you're going to be making these deposits and earning interest on these deposits. So I'm also going to make note of that the amount in the account is increasing. So now we're talking about a future value annuity. So we're allowed to use that future value annuity formula. Okay, so the future value is what we're looking for. We don't know that future value. The second thing we want to know is what's the payment? Well, we know the payment is $1,000. Our interest rate, 8%, so that's 0.08. The T value, we're doing this for 10 years, so our T is 10 years. What about our M value? It says that it is compounded semi-annually, so our M value is 2. So I want you to make note of something here. All of these problems, 2 things are always going to go together. You are making deposits every 6 months, and the interest is getting calculated semi-annually. Both of those things mean twice a year. So they're both happening twice a year. Okay, those 2 things are always going to match up. They're always going to go together. All right, so let's do our calculation. Our future value is equal to the payment times, and we have a fraction, 1 plus r divided by m raised to the m times t power. We're going to subtract 1 from that. We're going to divide by r over m. So let's plug in our values. Our payment is 1,000. We're going to multiply that times 1 plus our r value is 0.08. We're going to divide that by 2. And we're going to raise that to the power of 2 times our t value, which is 10. Then we're going to subtract 1. We're going to divide that by the 0.08 divided by 2. Okay, so I'm just going to put this right into my calculator and Desmos and then see what we get for that future value. Okay, so I'm going to type in my 1,000. We're going to multiply that times, and I'm going to do parentheses, 1 plus the 0.08. We're going to divide that by 2. I'm going to come outside of the parentheses, and I'm going to raise that to a power. I'm going to put parentheses around the power and let my calculator do all the work for me. So that's 2 times 10. And then I'm going to come outside of those parentheses. Make sure I come outside of the exponent, and then I'm going to subtract 1. Then I'm going to highlight everything at the top of that fraction. So the parentheses and the -1, I'm going to take my mouse, I'm just going to highlight all of that. And I'm going to hit divided by. So make sure that fraction bar goes underneath both the parentheses and the -1. Okay, make this a little bit bigger so we can see that. and then I'm going to divide by that R over M. So the 0.08, and then I'm going to divide that by 2. Okay, so it tells me I get $29,778, and then I'm going to round to the nearest 2 decimal places, or to the nearest cent. So that would be 0, and then the 8 rounds the 7 up to an 8, so 0.08. Alright, so our future value account started at $0 and then increased with all of our deposits and all of our interest to a total value of $29,778.08. Alright, now we want to know how much of this future value is actually interest. Okay, so in order to do this calculation, we want to take our future value, and we're going to subtract off the total amount of payments. And then whatever we have left over after that is going to be the interest. Okay, so our future value is $29,778.08. And then how much did we actually deposit? So we deposited $1,000 every 6 months. So that's twice a year. So $1,000 twice a year. So that's $2,000 per year. But for how many years? We did that for a total of 10 years. So what's 1,000 times 2 times 10? We get $20,000. So we deposited $20,000 of our own money into this account. Okay, so when I do that subtraction, I get $9,778.08. So this is the amount of money that the bank gave me in interest that we earned over the duration of the account. All right, so if you want to think about a formula for the total amount of payments that you deposited, you would take the payment, so that's the PMT, you could multiply that times the number of times per year that you made that payment times the number of years that you made those deposits. So that would tell you how much you deposited over the duration of the annuity. Future value annuities have an important application. Any account that is established for accumulating funds that is meant to meet future obligations or debts is called a sinking fund. So when you're doing a word problem and you see the words sinking fund, then you could know that we're talking about a future value problem. So let's look specifically at this example. A bond issue is approved for building a marina in a city. The city is required to make regular payments every 3 months into a sinking fund, paying 5.4% compounded quarterly. At the end of 10 years, the bond obligation will be retired with a cost of $5 million. We want to know what each payment should be into this sinking fund. Since we're talking about a sinking fund, then we know we're going to use that future value formula. So, future value is equal to the payment, and then we have that big fraction. It's going to be 1 plus r divided by m to the m times t power minus 1, and then at the bottom we're going to have r divided by m. Now we know that we want to solve for the payment this time and not future value. So let's rearrange this equation to where payment is by itself on one side. So this time we're not interested in the future value, we're interested in solving for the payment. Okay, so to solve for payment, we want to get payment by itself on one side. We're going to multiply both sides of this equation by the reciprocal of this fraction. So I'm going to multiply by r divided by m at the top, and then 1 plus r divided by m to the mt power minus 1 at the bottom. Okay, so I'm going to do that on both sides. Now when I do that, these will cancel, and the bottom and the top of that fraction will cancel, and on the right side we're just left with payment. So on the left side we're going to have future value times, and then we're going to copy and paste that reciprocal fraction on the left side. So we have to multiply both sides by the reciprocal of that big fraction. Okay, so that's going to allow us to solve for the payment that we are interested in finding. Okay, so what is the future value? So let's make a little list of all the variables. The future value here is the $5 million that we want to end up with at the end. So it says the bond obligation will be retired with a cost, that final cost of $5 million. So the future value of the sinking fund is $5 million. We need to know R. The interest rate is 5.4%. We're going to move that decimal place 2 spaces to the left. So that becomes 0.054. Okay, we need to know the M value. This says that we are doing compounded quarterly and we are making payments every 3 months. So let's remind ourselves what that means. Quarterly means we have 4 of those quarters, so quarter 1, quarter 2, quarter 3, and quarter 4. So we have 4 quarters per year. Our M value is 4. Also notice that we're making payments every 3 months. So when we talk about quarters, quarters are 3 months each. So we're making payments every 3 months, and what this also means is that the interest is getting calculated every 3 months as well. Okay, so M is 4 because we're talking about quarterly. All right, what else do we need? We need T. Okay, we're talking about doing this for 10 years, so our T value is 10 years. Okay, so the only thing we don't know then is the payment, and so that's what we're going to solve for. So we're going to plug everything in and see what we get for that payment. So our future value is $5 million. Multiply that times that fraction. That's my R value, divided by an M value of 4. And we have 1 plus our R value again, divided by an M value of 4, raised to the power of M times T. So that's 4 times 10. Up in that exponent. We're going to come outside of that and subtract 1, and that's going to tell us what that payment is. Okay, so I'm going to pull up Desmos, and we're going to type this in and see what that payment gives us. Alright, so I'm going to type in 5 million. Okay, I'm going to multiply that times that big fraction. So I'm going to put parentheses. It's always a good idea to put parentheses around everything at the top and the bottom. Okay, so I'm going to go ahead and just start with parentheses. Bring that back up. And then inside of that, I'm going to put that fraction. So I'm going to put my interest rate divided by 4. Okay, then I'm going to highlight all of that. I'm just going to hit divided by. We'll do our parentheses. And then 1 plus that interest rate, again divided by 4. I'm going to come outside of the parentheses at the bottom and raise that to an exponent. I'm going to go ahead and also put my exponent in parentheses, and I'm just going to do 4 times 10. And then outside of those parentheses at the bottom, so you want to be careful that you're not in the exponent, so I'm going to arrow out to make sure I am just a regular part of the denominator, say minus 1. Okay, so that is our payment that we wanted to solve for. So that's $95,094.67 when I round to the nearest 2 decimal places. Okay, so now let's look at part B. And I'm going to erase a little bit here to give us more room to do part B. And I'm actually going to change the question for part B, and I will update your notes to reflect this change. So it should be correct in your notes. But part B says how much interest is earned, and I'm going to change this to be during the 10 years. So for the duration of this annuity, we are contributing regular payments ourselves, and then the bank is giving us interest. So what we want to know is how much of this is interest, or how much of this future value is interest. Okay, so to calculate the interest on a future value account, we're going to take the future value and we're going to subtract off the total of all payments or deposits. We'll just call it payments. And then what's left over will be the interest. Okay, so the future value is $5 million. Now we want to subtract off the total of all of the payments. So the payment that we were making, we found to be $94.67. How many of these payments were we making? We were making these payments quarterly, so every 3 months, which is 4 times a year. So this is our yearly payments. So we're going to multiply that by 4, so that's 4 times a year we were making that payment, times how many years were we doing that? For 10 years. Okay. When I multiply all of that together in my calculator, I get over 3 million. Okay, and then when I do that subtraction, future value minus the total of all of the payments, then the interest that I get is a little over $1 million. Okay, so once again, if you want to find the total of all of the payments that you made into the annuity, payment times M times T. Okay, so the total of the payment times the number of times per year that you're making that payment times the number of years that you're making that payment. You multiply those together, that's going to give you the total of all of the payments that are being made into the annuity. Subtract that from the future value, and what's left over is the interest. Let's look at another example. What is the value of an annuity at the end of 8 years if $1,500 is deposited every month into an account earning 8.32% compounded monthly? How much of this value is interest? Okay, before we get started, let's make note that we have a deposit that is going in every month. So that is multiple payments. Is the value of this account going to be increasing or decreasing? So it looks like if we're depositing money into this, that we are going to, in the end, have a lump sum. So this looks like the amount in the account is increasing. If the amount in the account is increasing and we have multiple payments at regular intervals, then we know we're talking about a future value annuity. So the formula that we're going to use is going to be future value is equal to payment times that fraction. Okay, so we need to figure out what all the parts are. So the payment, $1,500, the R value, that's 8.32 written as a decimal. So I'm going to move my decimal 2 spaces to the left, so I get 0.0832 for that interest rate. We are depositing every month and compounding monthly, so our M value is 12. The T value is going to be 8, because we're going to do this for 8 years. Okay, so let's plug everything in and then we'll solve for our future value. Okay, so I plugged all of our values into the formula, and so now I'm going to pull up Desmos and we'll type it into Desmos and then calculate that future value of this annuity. So I'm going to raise that to the exponent power. I'm going to put parentheses and let my calculator do all of that work for me. If you want to simplify, you can simplify 12 times 8 if you want and put that into the calculator. But I'm going to just let my calculator do all those calculations for me. I'm going to highlight everything at the top of that fraction, and I'm going to hit divided by. I'll type in my fraction at the bottom. Okay, so let's just check it here, make sure. Forgot to type in my -1 at the top, so let's do that. Come outside of the exponent. You can hit these arrows to come outside of that exponent and then do -1. Okay, so that looks good. Let's double check. Okay, so it looks like we have our future value answer. We have 203,623.68. So, rounding to the nearest 2 decimal places there, I have 68 cents. And so our next question is, how much of this future value is interest? So to calculate the interest, we said we're going to do future value minus total amount of all payments You can also call these deposits. When we do that subtraction, what's left over is the interest that was earned during the length of the annuity. So the future value we know is $203,623.68. So we need to figure out what was the total amount of all payments. So we were making a payment worth $1,500 times how many times a month were we, or how many times a year were we making that payment? 12 times a year. So right now we have our yearly deposits or payments, and then we're going to multiply that by how many years were we doing this? Well, we're doing this for 8 years. Okay, so I'm going to put all of that into my calculator. Okay, so that's $144,000 worth of payments or deposits that we made into the account. Alright, now let's do that subtraction. Okay, so I get $59,623.68 that was earned in interest. Okay, so remember when we want to find the total amount of all payments, we're talking about that future value annuity. We're going to take the payment, multiply it times the M value, so how many times a year we're making that payment, times the number of years. Okay, and that's going to give you that total amount of all payments made into the annuity. Okay, the next example says that we have parents that are setting up a sinking fund in order to have $135,000 in 18 years for their child's college education. How much should be paid semi-annually into an account paying 5.2% compounded semi-annually? Okay, so before we decide what formula we want to use, we have a couple of things. First of all, I see the keyword sinking fund, which is telling me future value. I also see that I am making regular payments. So we want to know how much should be paid semi-annually. So this is a payment that's being made every 6 months, twice a year. So we're making multiple payments. Also, it looks like the end goal of this account is to accumulate money and to have $135,000 in the future. So the amount in the account is going to be increasing. So all three of these things should tell you use the future value formula. So I'm going to write out our future value formula here. Okay, but in this problem we already know the future value, so let's write that out. We know what the future value is. We know that in the future we want to have $135,000. Let's go ahead and just list out all our variables. We know we're going to do this for 18 years, so our t value is 18 years. We're going to be doing this semi-annually, so that's twice a year, so our m value is 2. Our interest rate, 5.2%, we're going to write that as a decimal, so that's 0.052. So the only thing that we don't know is the payment that we're going to be making semi-annually. So we're going to rewrite this equation to solve for payment. So I want payment by itself on one side. In order to get rid of this fraction that's being multiplied times payment, I'm going to multiply both sides by the reciprocal of this fraction. So we're going to flip that fraction. When we do that, the top and the bottom of these fractions cancel, top and the bottom cancel, and we're left on the right hand side with just payment. Now if I multiply by the reciprocal on the right side, I also have to multiply by the reciprocal on the left side. So we're going to have future value times that reciprocal fraction. So I'm going to write that flipped fraction right here, being multiplied times our future value. Okay, now I'm going to plug everything in. We have our future value of 135,000 times our R value divided by M, which is 2. Okay, so I have 1 plus my R value divided by that M value, which is 2. And I'm going to multiply that, or we're going to raise that to the power of M times T, so that's 2 times 18. And we're going to subtract 1. That's going to give us the payment that we want to make every 6 months or twice a year or semi-annually into this account. Okay, so once again I'm going to pull up my calculator. And we'll put all of this in. Okay, once again, just to be on the safe side, and there's lots of different ways that you could do this, but just to be on the safe side, anytime you want to enter in parentheses, it's a good idea. So 135,000 times, I'm going to put that fraction inside parentheses. May not always be necessary, but can't go wrong with a little extra precaution. So I'm going to take that fraction in the parentheses and I'm going to highlight that so I make sure that all of that goes at the top of this big fraction that I'm about to write. Okay, I'm going to come outside of that. Make sure you're only at the bottom and make sure you go to that parentheses just right outside of it. Raise that to the power of. And I'm going to let my calculator do the multiplication in the parentheses and that exponent. I'm going to come outside of the exponent. So right now my little cursor is up there at the top in the exponent. I'm going to hit the right arrow to come out of that exponent to be a part of just the big regular part of the denominator. Okay, and I think we're good. Let's just double check to make sure we have everything correctly. Okay, so I have 135,000, I have the top. Alright, so just want to make sure that we have that all typed in correctly before we walk away. Okay, so it looks good. I have then my payment for this account to be $2,310.05 when we round to the nearest 2 decimal places. Okay, so this is how much should be deposited every 6 months into this account so that we achieve our goal of $135,000 in 18 years. All right, our next example is a little more interesting than the previous examples. It's a little bit more involved. Okay, so we have Jane deposits $2,000 annually into a Roth IRA that earns 6.85% compounded annually. Due to a change in employment, these deposits stop after 10 years, but the account continues to earn interest until Jane retires 25 years after the last deposit was made. How much is in the account when Jane retires? Okay, so I'm going to set up a little timeline here of what's going on. So she deposits $2,000 annually, so once a year. Just write that down. There's our M value of 1 and our payment here being $2,000. Okay. Due to a change in employment, these deposits stop after 10 years. So here's the first 10 years. For the first 10 years, she's making regular payments of $2,000. Okay. But after 10 years, the deposits stop. So she stops making deposits. Okay. Soon as the deposits stop, then the annuity stops. So for the first 10 years, we have that future value annuity. After the payments stop, we are no longer using an annuity because an annuity requires multiple payments. So for the rest of the 25 years that she is not making deposits anymore, this now just becomes a compound interest problem that we would have seen in section 3.2. Okay. So we actually have two calculations that we're going to need to do. So let's figure out what happens at during the first 10 years. Okay, so we're going to use our future value formula just for the first 10 years. Okay, so we already said that the payments were $2,000. So I'm going to go ahead and just write out our formula with all the values entered. So that's $2,000. And then at the top, we're going to do 1 plus R. Our R value is that percentage written as a decimal. So we're going to move our decimal place over 2 spaces to the left. So that's 0.0685 divided by M. We're doing this annually, so our M value is 1. Raised to the M times T power, so that's an M value of 1. And we're doing this for 10 years. So just for the first 10 years, we have that annuity. Minus 1. Then we divide that by R over M. Now, some of these we can simplify before we type in, and you're always welcome to do that, or you can type this in exactly as we wrote it into Desmos and let Desmos do the simplification for you. Okay. It's up to you how you want to do that. All right. Let's close that out. So I'm going to have 2,000. Okay, so I have 2,000 times my 1 plus my R. Now I'm not going to do divided by 1 this time because divided by 1 is just that, so we'll just start to simplify a little bit here. Raised to the power of 1 times 10 is 10, so if you want to start simplifying these, that is totally fine. We'll come outside of the exponent, and then we're going to say minus 1. Okay, then I'm going to highlight everything at the top of that fraction. I'm going to hit divided by, and then I'm going to write just 0.0685. So our future value is $27,437.89. All right, so I'm just going to copy that down here. Now that's not our final answer yet. That's what happens during the first 10 years. So at the end of the first 10 years, this is how much we have sitting in that account. So for the first 10 years, it's a future value annuity. After that, she said stop making payments, stop making deposits, and then for 25 years, the money just sits in there. Now, this money right here is being redeposited into this compound interest account. Okay. So she's going to reinvest that in a compound interest account. She's not going to add any money to it. It's just going to sit in the account and earn interest. So we're going to make one deposit at the very beginning of this account, but we're not going to make regular deposits anymore. We want to figure out how much do we have at the end. And because, again, we're not making those regular payments, it is not an annuity anymore. It's just going to earn compound interest. So the formula we want to use for the future value of this compound interest is going to be A equals P times 1 plus R divided by M to the MT power. So this is just our compound interest formula. Now, what is the principal? How much is going into this account for 25 years? That's the $27,437.89 that came out of the future value account. So it's being redeposited into this compound interest account. Now it's the same interest rate, so that's not changing. It's the same compounding period, so it's still annually, so it's still divided by 1. So the M value is still 1. And then we do 1 times T. Now this is going to happen for 25 years. So we want to figure out what's the future value now of that compound interest account. Okay, so we're going to pull up Desmos. All right, so we're going to type in our value. And I'm not going to do divided by 1 again because that number divided by 1 is just that number. And in the exponent, I'm going to come outside of my parentheses and put an exponent. 1 times 25, I'm just going to write that as a simplified 25. Okay, so this is our final answer when I put that formula in. We have $143,785, and it looks like 10 cents when I round to the nearest 2 decimal places. That 6 is going to round the 9 up to a 10. Alright, so this is our final answer overall. Now some people think, oh, I need to add the $27,000 to this final amount, and that is not the case. So you want to be careful here. This $27,000 was deposited into this account at the very beginning of the 25 years. So that $27,000 is already in this future value. So we do not need to take the 27 and add it to this. This is the final amount that she has in the account after everything has been calculated in. Alright, so this example says that Mary starts a Roth IRA earning the same rate of interest at the time that Jane stops making payments into her IRA. So this problem is actually referring to the previous problem that we just did. We'll go back and look at that in just 1 second. How much must Mary deposit each year for the next 25 years in order to have the same amount at retirement as Jane? Okay, so she's depositing a certain amount each year. So this right here is telling me that Mary is looking to make multiple payments into this account. And it looks like she wants to accumulate, so the amount in the account is going to be increasing. So Mary is starting a future value annuity. And the amount that she wants, the future value that she wants in this account, is the same that Jane has at the very end of her account. So the future value that Mary wants is $143,785.10. Okay, so she wants to have the same amount as Jane. So I'm going to copy and paste Jane's future value, and that's the same amount that Mary wants to have in the future. Okay, so what we don't know is the payment, right? So how much should she deposit each year? That's what we don't know. She's going to be doing this once a year, so we're talking about an annual deposit, so M value is 1. she's going to use the same interest rate as Jane. So that was 0.0685, so same as Jane. And Mary is going to be making these deposits for 25 years. So our t value that we're going to use is 25 years. Okay. Also, for this, we are solving for the payment, so we need to rearrange our equation. We've done this a few times, so I'm just going to go ahead and write out what we know is going to happen. We're going to multiply by the reciprocal of that fraction. So I'm just going to go ahead and write this out. We've done this a few times, so you can look back at our notes to see that. Okay, so this is what's going to allow us to solve for that payment. Future value times the reciprocal of that fraction. So we're going to put in 143, 785.10. We're going to multiply that by the interest rate, divided by the m value, which is 1. And raise that to the m times t power. That's 1 times t value of 25, and then we're going to subtract 1 from that. And that's going to give us our payment. Okay, so I'm going to pull up Desmos. We'll type that in and see what we get. Since I'm dividing by 1, I am not going to type that into my calculator because dividing that by 1 is just that itself. But I am going to go ahead and highlight this, hit divided by, and we'll type in the bottom part of that fraction. I'm not going to type divided by 1 again. And the exponent I need is 1 times 25, that's just 25. Come out of that exponent and subtract 1. Okay, so Jane has to... Okay, so Mary has to deposit $2,322.73 every year for the next 25 years to have the same amount as Jane. When you're working with the future value formula, algebra can be used to solve for future value for the payment, for m, or for t, but we cannot use algebra to actually solve for the interest rate r. But we can use Desmos to approximate what the interest rate would be if we know everything else about a problem. So for example, let's say that we have a person that makes monthly deposits of $100 into an ordinary annuity. After 30 years, the annuity is worth $160,000. What was the annual interest rate that was compounded monthly during this 30-year period? We want to write our answer as a percentage corrected to decimal places. So we're going to use Desmos, the online graphing calculator, to actually approximate this interest rate. Okay. In order to do this, we are going to actually set this up as two different equations. So we're going to take the future value, and we're going to write that as an equation by itself, y equals. I'm going to set the right side of this equation also in its own equation called y equals. Now, when we go and look at this calculator, the calculator doesn't recognize r values. It's only going to work with x's. So if I want to solve for r, I'm actually going to ask the calculator to solve for x. So when I type it in, I'm going to replace the r's with x's. Okay. What we want to know is what value would it take, what x value would it take to make both sides or both of these equations equal to each other. Okay, so I actually have put this into your D2L course already. So if you go to your Exam 1 notes, right under Section 3.3 notes, you're going to see Section 3.3, Solving for the Interest Rate Using Graphs. So when you click on that, it's going to open up Desmos for you. And I already have this equation typed in. Okay, so I have the y equals 160,000. That's that future value on the left side. And I typed in the equation on the right side exactly as we see it. The 360 comes from multiplying 12 times 30, so there's the 360. What we're looking for on this graph is the intersection, so the point of intersection. The x value of the point of intersection is going to be the interest rate written as a decimal, and the y value, that output value, is the future value that we set y equal to. All right, so the interest rate is going to be the point of intersection, and it's the x value. So the interest rate, if I write that as a percentage, moving that decimal place 2 spaces to the right, would be 8.35%. Okay, so when you're working with future value and you're asked to find the interest rate, we can only approximate that using graphs and using Desmos. So here's another problem that's similar to the last one we just did to solve for that interest rate. This time I'm going to be making deposits of $1,000, and I'm going to do this for 5 years, and the future value is $5,840, and we want to solve for that interest rate again. So using that same calculator, I'm going to change my y value to match the future value of the annuity. So I'm going to change that to be 5,840. And I'm going to make some changes to my formula. I'm going to change that to 1,000. And remember, we're replacing r with x, so that's fine. So I have an m value of 1, so I'm going to change that to be 1. And then 1 times 5 is 5. So I'm going to change that to be a 5. Okay, everything else is going to stay the same. So you're welcome to edit that equation that I've already given. Now, in order to find the point of intersection, we need to go to a y value of 5,040. So you can zoom in and zoom out as much as you would need. You're looking for that green line. So there's the 5,040. So I'm just going to zoom in. And this graph is kind of that red graph, and I'm going to look for that point of intersection. Okay, so where the red graph crosses the green graph. And if you zoom out too much, it won't give you all the decimal places that you want. So you look at that, it says 0.078. If you zoom in, it's kind of a nice little feature of Desmos. If you zoom in, it gives you more decimal places. So we wanted to give it as a percentage, our interest rate as a percentage to the nearest 2 decimal places. Remember that the calculator, when you look for that point of intersection, that first point the calculator is going to give you is the interest rate written as a decimal. The y value of that point is going to be the future value that you set y equal to. So here, if I move my decimal place 2 spaces to the right, I get 7.77 as our interest rate percentage. Okay, so you have some homework problems that are going to ask you to find the interest rate of a future value formula. You're going to plug that information into Desmos, and you can use the link that I provided with you in D2L, and you're going to solve for that interest rate looking for the point of intersection between those two graphs.